In this lesson, we'll discuss how we measure solution concentration. It's something called molarity. And hopefully when you see this mole part of molarity, it makes you think about the mole or numbers of particles. Please have your note sheet, calculator, and periodic table handy as you work your way through this video. When we talk about solution concentration, we're talking about how much solute is in a given amount of solvent or solution. If you have a concentrated solution, you have a high concentration or a large number of solute particles. If you have a dilute solution, your solution has a low concentration or very little solute. When we talk about solution concentration in terms of molarity, we're talking about how many moles of solute we have in 1 liter of solution. That's how it's measured. So units are moles per liter or molar, capital letter M for units. So if you have a 3M solution, you have a 3 molar solution, that means you have 3 moles of solute per liter of solution. So if we have 1.50 liters of solution that contains 0.500 moles of sodium nitrate, we can calculate the molarity of the solution. Molarity equals moles over our volume in liters. So we want to solve for the molarity. We would need our moles in the numerator and the volume of our solution in liters in the denominator. If our volume wasn't in liters, we would have to convert it to liters. This is 0.333 moles per liter. Each of the numbers has 3 significant figures, so I put 3 significant figures in the answer. This is a fairly dilute solution, 0.333 molar. Next, we have 3.50 liters of a solution that contains 90.0 grams of potassium chloride, and we'd like to know the molarity of the solution. Well, again, molarity is moles over volume in liters. So if we don't have moles, which we don't, we can convert to moles using our mass. So here we need to be able to convert between grams and moles for a compound. 90 grams is to X moles, as 74.55 grams is to 1 mole. 74.55 is the molar mass for potassium chloride. 1 potassium, 1 chlorine. This gives you 1.21 moles. Now that we have moles, we actually can calculate molarity. Molarity equals the moles of solute over the liters of solution. Our molarity is 0.346 molar. Again, another fairly dilute solution. Next, we're asked to determine what mass of sodium hydroxide is required to make 1.50 liters of a 2.30 molar solution. So this time we know the molarity. 2.30 molar. And we know we want to make 1.50 liters of solution. So what we can solve for is the number of moles of solute. It's 3.45 moles. But that's not what we're asked for. We're asked for mass. So now we need to convert from moles to grams. X grams is to 3.45 moles, as 40 grams is to 1 mole. 40 grams is the molar mass of sodium hydroxide. And our answer is 138 grams. This is the mass of sodium hydroxide that you would need to make 1.5 liters of a 2.30 molar solution. And finally, we would like to know what mass of sodium chloride is required to make 250 milliliters of a 0.500 molar solution. So we have our molarity, and we have our volume in milliliters. Volume has to be in liters for molarity, no exceptions. There are 1,000 milliliters in 1 liter. So we're going to take and move our decimal point 3 places to the left. And we don't know our moles of solute. We get 0.125 moles of sodium chloride. But again, that is not the question. The question is for the mass. So X grams is to 0.125 moles, as 58.44 grams is to 1 mole. Again, 58.44 grams per mole is the molar mass of sodium chloride, 1 sodium, 1 chlorine, and we get 7.31 grams of sodium chloride to make the 250 milliliters of 0.500 molar solution. I'm rounding to 3 significant figures because that is the lowest number of significant figures between the 0.500 molar and the 250 milliliters. So hopefully now you know how to calculate the molarity of a solution, or to calculate one of the other variables given the molarity of a solution. If not, go back please and rewatch this video.